This is number 12, Iffat, on your practice test 7C. And you're told that the length of human pregnancies from conception to birth varies according to the distribution that is approximately normal, with a mean of 266 days and a standard deviation of 16 days. Let X and Y be the lengths of two randomly chosen pregnancies. What is the probability that the sum of X and Y will be more than 600? So the first thing we have to do is whenever you're in a normal curve, you know your first thing to do is to find z-scores. But in this case, we need to find the z-score from the mean and standard deviation as always, so we have to find the mean and standard deviation of X plus Y. So we know to find the mean of X plus Y, we have to take the mean of the distribution that X comes from and add the mean of the distribution that Y comes from. So the mean that the distribution of X comes from is 266, and the mean of the distribution that Y comes from is also 266, because they're both pulled from the same distribution of human pregnancy lengths. So the mean of X plus Y will be the sum of those two values, which is 532. Now the standard deviation. The standard deviation of X plus Y cannot be determined by adding the standard deviations. We know if these pregnancies were pulled independently from one another, and it didn't say that, so I might mention my concern in my response, but we can add the variances that each of those X's and Y's come from, or the variance of the distribution that each of them comes from. So the variance of the distribution that X comes from is 16 squared. And the variance of the distribution that Y comes from is the same, 16 squared. And then we know our standard deviation will be the square root of that sum, which is about equal to 22.627. So now we have a standard deviation and a mean. Now we can find our z-score for the sum of the lengths of those pregnancies to be more than 600. So our X is 600 minus our mean, we now know, is 532, divided by our standard deviation, we now know, is 22.627. We get a z-score of about 3.01. And then, of course, if we go to Table A, we can determine the area below a z-score of 3.01. And it is 0.9987, so the probability that z will be above 3.01, we know, of course, would be 1 minus that 0.9987, which would be 0.0013. I hope that helps as well. Iffat, I'm going to be on the road driving, but feel free to send me any other questions that you might have, and I can stop and answer your question or make you a little video.